Heyo, welcome back to WarGearSchool. I'm still sick, but I hope you still don't mind. Today I want to talk about what actually happens when TNT explodes. So, how does an explosion apply force to entities and make them fly? In our case specifically, how does TNT make other TNT fly? Because that's what we do. And also, how does TNT destroy blocks? This video is a little more technical compared to the last one, but I'd consider it essential knowledge, which is why it's so early in the series. To be honest, the next few ones will also be a little technical, but then we can delve into canon technology. You could skip all of these, but then you would be going blindly into the tech part and not really understand how it works. So, when TNT explodes, to find out how an entity will be affected, a bunch of rays or lines are drawn from the center of the explosion towards points on the entity to find out how exposed it is. Servers usually have this neat feature nowadays that you can actually look at these rays before the explosion even occurs. So here you can see these rays that are drawn to calculate exposure, because then we look at each ray and check if it's obstructed by some sort of solid hitbox. And the more of all of these rays hit the projectile unobstructed, the more exposed we consider it, right? So for example, I'm going to do it again. You see that all of these lines are green, right? So the projectile, which is the TNT that will fly towards the opponent, is fully exposed to the explosion. But if, for example, we put a slab here and do it again, then we see now the projectile is fully not exposed to the explosion. And if, for example, we put a bar here, then we see that only the middle rays are now obstructed. Right. And then we check the distance between the propellant and the projectile, measured from the center of the explosion to the feet of the projectile. And then to calculate how much velocity will actually be added to the projectile, we do some fancy maths that includes that exposure and that distance and some other factors, but these are the two most important to us. So the more exposed the projectile is, the more velocity will be added, and the shorter the distance is, the more velocity will also be added. And then the direction that the projectile will fly in is calculated by looking at from the center of the explosion to the projectile feet. And it doesn't matter which rays are obstructed if the relative position of the propellant to the projectile doesn't change, then the projectile will also just fly into the same direction every single time. To demonstrate this really quickly, because that might have sounded like a bunch of complicated gibberish, I'm actually going to load 2 propellant now and shoot. We'll be able to see that this flies straight ahead. But if I put a bar here and a solid block, I'm pretty silly. Just destroyed my setup. Now let's think about this real quickly. You might think that because the rays from the right side are going to be obstructed, you might think that it now flies to the right, right? Because more pressure now comes around this corner. But that is not actually what happens. The rays are indeed obstructed, but it still flies straight forward, just not as far, because it is less exposed due to the bar. But if we do change the relative position of the propellant and the projectile, then it will indeed fly differently. So if I let the propellant travel sideways, now we can see it flies to the right. That's how it works. And if multiple TNT explode, so multiple propellants, they will apply their velocities to the projectiles independently. And in the scene, we call the total amount of velocity that propellants add to projectiles pressure. Just something, some terminology, some lingo to know. Since I was talking about the feet of TNT and the explosion center, I want to elaborate what I actually mean. The feet of TNT, like for all entities, is at the bottom of their collision box, centered. So if you imagine this is a prime TNT, we would say the feet is right at the bottom and centered. So actually this point right there, right? So that's the feet of TNT. And the center of an explosion that's caused by prime TNT is 1 pixel above its feet. So 1/16th of a block above the TNT. So probably like right there or something. This actually means that if two prime TNT are on the exact same height next to each other and one explodes earlier, it will apply a slightly downwards force to the projectile, since the center of an explosion is slightly higher than the feet, and the direction is calculated from the explosion center to the feet. What that means effectively is that, for example, if you want a quote unquote neutral angle or like a neutral direction to shoot the TNT into, what you want is to elevate the propellant 1 pixel higher than the projectile. For example, if we take a campfire and we place it here, a campfire has a top hitbox of 7 pixels, and we know that the extended hitbox of a wall is half a block higher than it itself. And half a block is 8 pixels, so we have a difference of 7 pixels here to 8 pixels here. And the explosion center is a pixel above the feet of TNT. So we will have an explosion at 8 pixels here and projectiles at 8 pixels here. So the direction will be perfectly forwards. Yep, just wanted to show that. I'm talking about pixels for a bunch here. In coordinates, 8 pixels would be 0.5, right? Because Minecraft is 16 pixels per block based. Entities can of course be at any position, not just these 16 pixel per block steps. But yeah, block hitboxes usually align to these single pixel steps, but there are some exceptions. Like for example, chains have like 9.5 pixel boundaries and such. But yeah, that's it for the like exposure and pressure part. Now for block destruction, how does TNT actually calculate how blocks are destroyed, or explosions in general? There are other things that cause explosions. I sometimes forget that. So for block destruction, we also, again, cast rays from the center to the of the explosion evenly outwards, and each ray has a slightly variable intensity. And then we step along each ray and always reduce its intensity according to the blast resistance of the block that's there, if the block is anything other than air. And if the remaining intensity of the ray is larger than 0, then the block is added to the list of blocks to blow up at the end of the game tick. And then if the remaining intensity is not above 0, we stop looking at that ray. I will show a few explosions. Moss, for example, has a blast resistance of 0.2. So when the rays are cast outwards, they will always be reduced. There is a formula. I don't want to say the full formula, but 0.2 is very little blast resistance, so the ray's intensity only reduces very slowly over time, right? And that's why moss is destroyed in a very wide area by TNT. Stone, on the other hand, has a blast resistance of 6, so the rays are going to weaken significantly faster. And something that I want to mention that maybe you noticed personally, these explosions, their shapes can look different. And that's because, at the beginning I said that rays are cast outwards evenly from the center of the explosion with varying random intensity. So that's why these holes will look different every single time. And then we have endstone, which has a blast resistance of 9. And that, of course, is going to eat the rays up even quicker than that. And water stops explosion damage immediately because water itself has a blast resistance of 100. So the intensity of all the rays that start in the water is immediately reduced to 0 and nothing explodes at all. And this is something that you also probably know. Like the fact that TNT in water doesn't destroy things, but now you know why. Because when the rays start at the center of the explosion, they are in water, their intensity is reduced fully to 0, and so we stop looking at those rays. We don't care about them anymore. Yeah, and all of this is why the WarGear scene mostly plays with endstone, since it has a very high blast resistance. 9, I think, is the highest you can get in existing blocks before explosions don't destroy anything anymore. And so yeah, we play with endstone. One trick that might seem weird, but that should make sense to you now, is slab armoring. And I'm going to quickly show what happens, and you can think about why that might be. So you might have initially felt like, at least these trapdoors are going to be destroyed or something. But it turns out actually just this tiny little hole is punched in there. So why? You might notice that these are bottom-placed slabs. So when the TNT is primed, it falls down here, right? And then the explosion occurs a pixel higher than its feet. But when the rays start, they check what block space they are in. And because they are in the same block space as these bottom placed slabs, they encounter this blast resistance of 9 of these endstone slabs. Because the rays don't care about the shape of the block they're in, they just care that this block has a blast resistance of 9. And so this effectively, to the game, feels like an explosion going off within endstone. And this immediately reduces the strength of all the rays by enough that nothing else will be destroyed. Like not even moss. I can demonstrate that really quickly. Like if I put moss down here, even that moss will not be destroyed. Yep, little magic trick. So yeah, that's it. As per usual, if you have any questions, feel free to ask them. If you want to see more WarGear stuff, feel free to like and subscribe. And yeah, see you next time.